Whether you're a research hospital or a pharmaceutical company, there are several obstacles you will encounter throughout the research life cycles you oversee. How can you ensure your data governance targets are met and that only relevant people are working with the research data? Do you have the computing resources you need in place? How flexible are they? Are you needlessly wasting money on high-powered systems that lie dormant most of the time? Are your teams able to easily collaborate with everyone, from project managers to data scientists, both in-house and with partners across the world? Is everyone using the same compatible tools and systems? In a multi-site collaboration, how much control do you have over the environment and nature of your research? Most of the published research work this decade is not truly reproducible. How are you going to ensure that yours is? How do your teams gain access to all the best tooling? And are those tools compatible with everyone else's? How do we overcome all this? By utilizing a digital research environment that deals with all of these issues and more. So, what is a DRE? It's a collaborative online platform where modern health data science and research teams come together. A digital research environment should provide you with everything you need, ensuring your research adheres to the FAIR data principles by granting access to everything from data cataloging and de-identification tools, transformation and analytics, right through to publication and reuse. Let's look at an example workflow. The dataset library provides a source of truth for all your available datasets. You can search the library for the data you're interested in, then view the field-level metadata associated with them. Let's say we're interested in working with this biomarker data. We have the option to push anything from the library into one of our workspaces. The authentication process for obtaining that data can be set by the organization. Let's jump into a workspace to see how we can start working with our data. You can access the login screen for workspaces through a browser. Once you have obtained your user credentials and set your password, you will log in and be presented with multi-factor authentication, which will send a notification to your phone which you must approve to log in. Workspaces are the unit where users can collaborate on data and analytics. They could contain a project with a single user, a group project containing 50 people, or whatever level of organization suits your team best. This allows you to build up a natural model for data access, data sharing, and supervision, and it can be easily scaled. If we look in the Datasets tab, we can get an overview of the available datasets. Here's the biomarkers one we selected from the dataset library earlier. It shows the columns, metadata, and field types. From this view, you can quickly preview the data, or filter and combine it with other datasets in the workspace. If we select to analyze the data, it will quickly open a data frame and a number of analytical modules that cover the core of medical statistics. From this view, you can create, delete, or modify the data. Every change made to a cell will be captured in your workspace's audit. Let's look a little deeper at this data. As you select your X and Y values, you'll notice that the modules on the right will filter down to the most relevant for those data types. Let's say we want to generate a scatter plot of our p-tau and t-tau results. We would expect to find a correlation here. And it certainly looks like there is. Whenever you create these visualizations, you can then view the underlying R code that was used to generate them. From here, you can either send that code directly to the workspace's inbuilt R console, or you can copy that snippet and use it as part of one of your own scripts. That's something nice and simple, so let's try doing something a bit more interesting. If we generate another scatter plot of the patient's A-beta and p-tau results, then we end up with this. It doesn't seem like much until we fill the graph with the ApoE results. Now we start to see that lower A-beta seems to correlate very well in participants with 2 copies of the E4 allele, indicated on the left side of the graph, which we know is a strong risk factor in Alzheimer's dementia. Now I want to look at just the A-beta results, so let's pull up a box plot. Simple enough. But we have some longitudinal data in here as well. We have their baseline readings and also the measures from their follow-up visit. Now we have two box plots, and just by eye it does look like there is a bit of a difference there. Their A-beta readings seem to have dropped a little on their follow-up. Well, with just a few clicks, we can go from this simple exploratory analysis to looking at the statistical significance of what we're looking at. We've now switched to a t-test, and given the output, it looks like it is significant. It's useful to build reports that can be automatically updated each time they are generated. This report has been generated using a LaTeX script that references datasets and scripts within this workspace. The code snippets we pulled from our visualizations earlier have been inserted into this script, as you can see here. As time goes on and more data is added to the workspace, you can simply rerun the script to generate a brand new report with the most up-to-date information. As well as having inbuilt tools, users are free to develop their own R-Shiny apps within the workspace. These interactive apps allow a wider multidisciplinary team to easily collaborate and engage with the data. This can help with exercises like prototyping, reporting, along with many other tasks. Your team can write and publish anything, from a small table statistics app like this one, to something much richer and more comprehensive like this Circos genome viewer. This video has illustrated a short workflow through the digital research environment. To learn more about the Aridhia DRE, please visit our website at www.aridhia.com or email us at info@aridhia.com.